Hello Flight Simmers and welcome back to Alpha Hotel Flight Simulator Training. This is flight lesson number 5 in our instrument flying series. In this part of the series, we're continuing to discuss procedures we need to learn to execute to be able to fly all different types of instrument approach procedures in preparation for learning about instrument approaches themselves. In this video, we'll take a look at holding patterns. Before we get started, I'll mention that this video assumes that you're familiar with the basics of instrument flying and also have a handle on the basics of VOR navigation, NDB navigation, and GPS navigation. If you're not familiar with or proficient in these topics, I'll leave a link to my videos on these topics in this video's description. It's also a good idea to be caught up with a whole series on instrument flying to this point, so I'll leave a link to that playlist as well. So what is a holding pattern? One thing that airplanes are not particularly good at is stopping in midair. So the holding pattern is a maneuver that's flown to keep an aircraft from proceeding on course if it's already airborne and a delay is needed before it can keep going. It's a racetrack or oval-shaped maneuver that allows an aircraft to stay in a small parcel of protected airspace for as long as the delay is needed or until it's determined that the aircraft needs to divert along a new route or to a new destination. Holding patterns are typically used when something has gummed up the airspace ahead of you. Maybe somebody did an extreme short field landing by not utilizing their landing gear and has closed the only runway at that airport to all other landing traffic. Or maybe weather is constraining the routes in a particular area so that fewer airplanes than usual can get through it. Typically, if there's a known delay en route before an aircraft gets airborne in the real world, ATC will hold the aircraft on the ground rather than in the air. But if an unexpected delay occurs while airborne, holding patterns are the tools by which ATC and pilots slow down or stop air traffic. Now, if you're not using any sort of ATC in flight sim, it's unlikely that you'll need to use holding patterns en route, and it's probably equally unlikely that you'll give yourself one. But holding patterns are used pretty extensively in instrument approach procedures. There's almost always a holding pattern at the end of a missed approach procedure, and holding patterns are often used in lieu of a standard procedure turn at the beginning of an instrument approach. So if you want to be a well-versed instrument pilot, even in the sim world, it's good to know how to enter and fly holding patterns. A holding pattern is typically flown at what's called a holding fix, and this can be just about any nav aid or fix you can find on a chart, including VORs, NDBs, VOR DME fixes, VOR cross radial fixes, DME or cross radial fixes on a localizer or localizer back course, and GPS waypoints. Holds can be depicted on en route and arrival charts, but in the real world, they're always issued by air traffic control. So in the real world, you don't fly a holding pattern that's published on an en route or arrival chart without instructions from ATC to do so. It's also important to note that while ATC can issue you a hold that's published on a chart, they can also issue you a non-published holding pattern at any fix they deem necessary. The maneuver itself is very easy to fly. You track the inbound course to the holding fix, then you make a 180-degree turn, typically to the right, at a standard rate. Once you pass the holding fix outbound, you fly the outbound heading, typically for 1 minute. Then you make a 180-degree turn back onto the inbound course and fly it back to the holding fix. You then repeat the process as long as the delay is needed. Since each of the turns takes 1 minute at a standard rate and each of the legs takes 1 minute, the entire maneuver takes 4 minutes to fly. This is what we call the standard holding pattern. In a standard holding pattern, all turns are made to the right, and the legs are 1 minute long if you're below 14,000 feet, and if you're above 14,000 feet, they're a minute and a half long. There are also maximum airspeeds or airspeed restrictions that you can fly in a hold, and what those maximum speeds are dependent upon the altitude that you're holding at, and they're also dependent on whether you're in the U.S. or whether you're outside of the U.S. The U.S. has its own set of restrictions, and then anything outside the U.S. is governed by ICAO. So for the airspeeds restrictions in the U.S., if you're holding at altitudes up to and including 6,000 feet, the maximum indicated airspeed you can fly in the hold will be 200 knots. If you are above 6,000 up to and including 14,000, then the maximum airspeed is 230 knots. And if you are holding anywhere above 14,000 feet, then the maximum indicated airspeed is 265 knots. There is a caveat in the rules that say that if your aircraft is not capable of flying that speed, if that is too slow for the aircraft, if your minimum safe speed is above that, then you can fly that higher minimum safe speed, but you do need to let ATC know about that. You would see this with the MD-80s quite a bit. The minimum safe speed, a lot of times when the aircraft was heavy and without putting out any sort of flaps or slats, the minimum safe airspeed was up to close to about 250 knots. So if they were holding, say, at 12,000 feet, in order to fly that airspeed restriction of 230 knots, they would have to put slats out, which would burn more fuel, which was kind of counterproductive. So they would have to hold at 250 knots, even at 12,000, where the maximum speed is 230. They would just have to let ATC know, hey, we can't go that slow. We're going to have to do 250. In fact, if they got heavy aircraft, particularly in the MD-90s, sometimes the speed would get up closer to 260 knots that they would have to do. And the speeds for ICAO are very similar. They're a little more simplified in the lower altitudes, but a little more complicated in the higher altitudes. If you're holding anywhere at 14,000 feet and below, then the maximum airspeed is 230 knots. If you're holding basically above 14,000 but up to 20,000, then the maximum speed is 240 knots. And then if you're between 20 and 34, then the maximum speed is 265 knots. And above 34, where most aircraft are not flying indicated airspeeds but are flying Mach speeds, the maximum speed is going to be Mach 0.83. And one final thing I'll mention about holding pattern speeds: if you are flying an aircraft that is capable of flying faster than these speed limits, and you need to slow to these speeds as you enter the hold, what the examiner is typically looking for on a check ride is that you slow no earlier than 3 minutes prior to the hold, but they want to make sure that you have arrived at that speed, that you've slowed to that speed before you hit the holding fix. So you basically have a 3-minute window prior to arriving at the holding fix to get your aircraft slowed down and to that maximum holding speed. So there are also non-standard holding patterns as well. With non-standard holding patterns, you may have left turns instead of right turns. The leg length can be varied. It may be different, and it may be given in minutes, or it may be given in miles instead of minutes. And it may have a non-standard speed restriction. It may have something that's more restrictive, or it could have a speed that's higher than what is normally used in a standard holding pattern. With a published non-standard hold, anything that's non-standard will be depicted on the chart. So if it has left turns like this one right here, you can see it's depicted as having left turns. So we have to look at it and look, oh, hey, that's got left turns there. If it has a non-standard length, that will be printed somewhere on the chart. And then if it has a non-standard speed restriction, that will also be published somewhere on the chart, close to the holding pattern that we can see. If ATC gives you an unpublished hold and they want a non-standard hold, any element of the hold that is non-standard must be included in the holding clearance. And then anything that they don't include in the clearance will be assumed to be standard. In the real world, the holding clearance will always contain 3 things. It will always contain the holding fix, the altitude to be maintained in the hold, and an expect further clearance, or EFC time, which is an estimate of when ATC expects they will be able to release you from the hold, which may or may not be accurate. As we mentioned earlier, there are published or charted holds that are published on arrival procedures and en route charts and even approach charts. And primarily these are used to simplify holding clearances. Instead of having to tell you what radial that you're going to hold on and which way you need to turn, they'll just reference you to a a hold that's published on a chart at a certain fix, and then tell you to hold as published. Then you can look at the chart, you can see which direction it turns, what radial you're supposed to hold on, if it's a VOR hold, what the leg length is, if any of that is different than standard. All of that is there on the chart. An example would be if we're coming in on the Bramer 7 arrival into Kansas City, Missouri, we have a holding pattern published here at Bramer VOR, and all they would have to do to clear us into this hold is tell us proceed to Bramer VOR, hold as published, maintain 8,000, and expect further clearance at whatever our expect further clearance time is. So let's take a little closer look at what information is published on a published holding pattern on an en route chart or an arrival chart. You can see we have the hold depicted on there, and that will tell you, it has arrows there to tell you which way you fly the hold, and that will tell you which way you need to turn. So we can see here that this is a right turn or a standard holding pattern here at Bramer VOR. It gives you the inbound course on the bottom side here, and it gives you the outbound heading on the other side here, and then it tells us which radial we're supposed to hold on. So here, when we're holding at Bramer VOR, we're holding on the 054 degree radial, and if we're flying inbound on the 054 degree radial, that's going to be a 234 degree inbound course. So in the real world, if ATC gives us an unpublished hold or something that is not charted, we have to get a little bit more information from them. They will still give us the holding fix or where we are supposed to hold, but they will also tell us the direction we're supposed to hold from that fix. So in other words, an example of this would be if they want us to hold at, say, Pine Bluff VOR, they will tell us which direction from that VOR we're going to hold. So they would say hold north of Pine Bluff VOR. They will also typically give us a specified radial for a VOR or a course or inbound track if it's something like an NDB or a GPS waypoint. For example, if they wanted us to hold north of Pine Bluff VOR, they would tell us hold north on the 360 degree radial. If they wanted us to hold north of a NDB or a GPS waypoint, they would say hold north on the 180 course or 180 track inbound to that fix. And that would tell us precisely where we're supposed to hold. They're also going to give us the DME distance if they want us to hold at a DME fix. For example, if they want us to hold instead of at Pine Bluff VOR, they want us to hold 15 miles north of Pine Bluff VOR as we're coming down. They would clear us to hold, they would say, hold on the Pine Bluff 360 degree radial 15 DME fix, which would tell us to hold 15 DME away from Pine Bluff VOR. They're going to tell us the directions of turns if it's non-standard. If it is a left-hand pattern instead of a standard right-hand pattern, they will tell us left-hand turns. If they don't say anything, we assume standard, so we assume right-hand turns. They're going to tell us the length of the legs, again, if it's non-standard. If they don't say anything, we assume it is that either 1 minute or 1.5 minute leg length, depending on our altitude, but they can do this they can adjust the length either in minutes or in miles. They could tell us fly a 2-minute pattern, or they could fly 5-mile legs or 10-mile legs. But again, if they don't say anything, we assume that it's going to be the standard length. They will still give us the altitude to be maintained, just like they would in a published holding clearance, and they would also give us an expect further clearance time. And again, just as a reminder, any element that they don't include in the clearance, we assume will be standard. And just like with our procedure turns in the last video, every time we make a turn or leave a turn in a holding pattern, we want to do our 5 T's. And our 5 T's were time, turn, twist, throttle, and talk. So every time you either start a turn or finish a turn in the holding pattern, you want to go over to your timer and either reset the timer if you're entering a turn, or start the timer again if you're starting a leg that you need to time. Turn to the appropriate heading or roll out on the appropriate heading. Twist, remember to twist your VOR course selector if you're in a VOR hold to the inbound course, so that when you make that inbound turn, you know that you're on it. Throttle is more talking about when you're doing a holding pattern as a procedure turn, to remember that when you enter the hold and when you turn inbound in the hold, to descend to the appropriate altitude. And then talk is more for the real world. When you cross the holding fix the first time, let ATC know that you are entering that holding pattern. So let's look at a couple of sample holding clearances and sample holding patterns and look at how we would fly those. We're not going to worry about the entries too much right now. We're going to get to that here in just a little bit. We'll just assume that we're coming inbound on the radial that we're going to hold on to make things simple and just look at how to basically fly the pattern right now. We're also going to start with a very simple, very standard holding pattern at a VOR to start off with. So we'll assume we get the following clearance: Cessna 172 Alpha Hotel, cleared direct to the Pine Bluff VOR, hold north on the 360 degree radial, maintain 5,000, expect further clearance at 1800Z. So I've got my Pine Bluff VOR popped up right here. I'll go ahead and draw in the 360 degree radial. He didn't say anything about turns, so we know we make standard turns to the right. And if we're tracking inbound on the 360 degree radial, that's going to be a 180 course to the VOR. Remember, if you're tracking inbound on a radial, you're actually flying the reciprocal course, so that's going to be 180. And then the outbound course is going to be 360. When we hit the VOR and turn around and fly outbound, that will be the course that we fly. He also didn't say anything about leg lengths, so we assume that those are going to be the standard 1 minute leg lengths. So we'll assume we are tracking down on the 360 degree radial already. We're already established on the radial. We're just going direct to the VOR like he's cleared us to do. We're on that 180 course to track that radial inbound. And then what we're going to do is we're going to fly all the way to the VOR. We're going to wait until we get the flip from the to the from. That tells us that we passed the station, and then we'll start our 5 Ts. We will not have to do anything with time on this leg because we don't time the turn. So we'll just make sure that our clock is up and it's on 0. We'll go ahead and turn and make that standard rate turn around to 360 degrees. Twist, we'll go ahead and twist our OBS around to 180, so we will have a good inbound course to track if we weren't on that already. And then we would throttle if this was like a procedure turn or they've cleared us to descend. Once we hit the VOR, then we can throttle back and descend. And then talk is just reminding us to key up and tell ATC that we're established in the holding pattern. Once we complete that 180 degree turn, we roll out on the 360 heading. We look for that VOR to flip from back to 2. That tells us that we are being the VOR. And then we're going to do our 5 Ts again. So time, we're going to start our timer and time for 1 minute. Turn, we should just check that we're rolled out on a heading of 360. Twist, again, this is a chance to make sure that we've got this turned to our inbound course of 180 for this hold. Throttle, we shouldn't need to do anything with the throttle now, and we've already reported, so we don't need to do anything with our talking. So we're going to fly this 360 heading out for 1 minute, and when we get to 1 minute, we'll hit the 5 Ts again. Time, we'll reset our timer back to 0. Turn, we'll make that standard rate turn around to the 180 heading. Twist, again, this is one more chance to catch to make sure that we've got this twisted to the 180 course on our VOR indicator there. And then throttle, we shouldn't need to do anything with that. And talk, we don't need to do anything with that. So once we've rolled around to this 180 heading, hopefully it centered us up on that 180 course or that 360 radial inbound. And once we get level on that course, we'll go ahead and time. We are going to reset our timer and time the inbound leg, and we'll talk more about why we're doing that here in just a little bit. Turn, just make small turns. If you're not centered up on the course, make small turns to get back on that radial again. Twist, you have already had 3 chances to twist to it at 180, but if you forgot to do that, make sure you do that at this time. Throttle, you shouldn't need to do the throttle, and we've already talked. And then we're just going to fly this leg until we hit the VOR. When we hit the VOR, we note the time to see how long that leg was to make sure it was a minute. And then we start the whole cycle back over again and go back around up to the north. So if you're flying just a ATC cleared holding pattern, you'll go ahead and make as many turns as they want you to make, or if you're just doing this for training purposes, as many turns as you would like to make. If it's a procedure turn in lieu of a holding pattern, all you have to do is one trip around the holding pattern, and then you can proceed inbound on the approach course. All right, so I am tracking inbound on the 360 degree radial, so it's a 180 course to the Pine Bluff VOR. We'll assume that we get that standard holding clearance that we've been discussing. They say proceed direct to Pine Bluff VOR, hold north on the 360 degree radial, maintain 4,000 feet, expect further clearance in 30 minutes. So we've got things set up for the hold. I've got my elapsed timer set up here. We can see we've got Pine Bluff dialed into the number 1 VOR. We have this set to nav and VLOC, so we are receiving the VOR and not the GPS. And so we'll just track inbound until we get the flip from to to from. That tells us we've crossed the holding fix, and then we'll start in with our holding procedure and our 5 Ts. Okay, so we're within 1 mile DME to the VOR, and being up at 4,000 feet, that means we're probably pretty close. Needle is starting to get more sensitive, so we're not going to chase it. We're just going to make very small corrections to try to keep it centered up until we pass over the VOR. And we're just waiting for that to flag to flip to a from flag, and then we can go ahead and turn to our outbound leg. Okay, so we've lost the to flag, looking for the from flag. That'll tell us that we've crossed over the VOR. There's the from flag, so we'll do our 5 Ts. The timer is set up. Turn, we'll go ahead and turn to that outbound course of 360. And then twist, we want to make sure this is the VOR is set up for that inbound course of 180, which it already is, since that's what we tracked inbound on. And then throttle, we don't need to descend, and then talk, we'd report established in the holding pattern. We're air traffic control in real life. So once we get around to that outbound heading of 360, then we'll go ahead and start our 5 Ts again. All right, so we are leveled out on the 360 heading. I'm waiting for this to flip from a from back to a to. That tells me that I have passed the VOR. And then we will start the 5 Ts from that point. There's the to flag, so I'm going to go ahead and time. And I'm starting to count up, so we're going to fly this outbound for 1 minute. Turn we've already done. Twist, again, this gives us a chance to make sure that we've got that inbound course dialed in there of 180, which we do. Throttle we don't need to do. We're just going to hold at 100 knots, and then we've already reported established in the hold. So all we're waiting for now is for this to get up to 1 minute. All right, there's my minute. So my 5 Ts, I'm going to go ahead and reset my timer back to 0. I'm going to go ahead and turn inbound to 180. Twist, we've already twisted to the 180 course, and then throttle, we're good there, and we don't need to talk. So that's our 5 Ts on this leg, and then I'll fly to the heading of 180. But what I'm really looking for is that I get inbound on this 180 course inbound to be on the inbound holding leg. And then once I am on that course, I can go ahead and start the 5 Ts again. You can see the course is coming back through. So I just need to adjust my heading. We'll go a little bit left here to get it kind of centered up here. And I would say we're heading back towards the VOR, so I'm going to go ahead and start the time the inbound leg, and make sure it takes a minute to get inbound there. We'll put a little bit of a turn here to get this centered up so that we're tracking inbound on the 180 degree radial. And then we'll wait for the to from flip to determine how long that leg was and if we need to make any adjustments on that outbound leg. And remember that we're really close to the VOR. We're only about a mile away from the VOR, so things are going to be pretty sensitive. The needle is going to swing pretty quickly, so just make very small corrections. And there's the flip from the to the cone of confusion. Took about 1 minute and 10 seconds to get inbound there. And then we'll go ahead and start the next leg of the holding pattern. So time, I've reset my timer, and I'm going to go ahead and turn to the outbound course. And we're established in the holding pattern, and then now it's just a process of repeating this procedure as we go around the holding pattern, and then making adjustments for the wind, which we'll talk about here in just a little bit. So let's look at a bit of a non-standard holding pattern here. Let's assume we get this clearance, Cessna 172 Alpha Hotel, cleared direct to Pine Bluff VOR, hold north on the 360-degree radial, left turns, 5-mile legs, maintain 5,000, expect further clearance at 1800Z. So we'll go ahead and draw what the pattern looks like up here. We've got our VOR here. We've got our 360-degree radial. And again, we're going to make left turns instead of right turns, so that puts the holding pattern on the other side of the VOR. Otherwise, the pattern looks basically the same. We still have our 180 course inbound. We still have our 360 heading we're going to fly on the outbound. But the other thing that has changed is now we're going to do 5-mile legs. So instead of timing the leg outbound, we'll just fly to 5 DME, and then that's our signal to turn back around. So flying it, we fly it very much the same as we fly the other one. We'll come inbound on this 180 or 180 course or 360-degree radial inbound. We wait for the to from flip on the VOR, and that tells us to start our 5 Ts. So time, we're really not going to need to do anything with the time since we're doing distance, so we can ignore that. We'll turn around to that 360 heading. We'll twist the VOR course to the 180 inbound if we haven't done that already. And then throttle will do if we need to descend, and then talk, we'll go ahead and report established inbound in the real world. Again, we're looking for the to from flip of the VOR to flip from to or from back to to. That will tell us we're established on the outbound leg, but we don't need to time it this time because we're going to fly until we get to 5 DME, and that will be our signal for us to turn around. So time, we don't really need to do anything with that. We've already turned. Twist, that's the reminder to make sure that we have the VOR set up for the 180 inbound. Throttle, we shouldn't need to do anything with that, and we've already reported established, so we don't need to do anything there. So we fly until we see the 5.0 on the DME, and at that point, we go ahead and do the 5 Ts again. So time, really don't need to do anything with that. Turn, we'll go ahead and turn back around to that 180 inbound heading and get on that 180 course or that 360 radial inbound. Twist, another reminder to set that course correctly, and then throttle and talk again, we really don't need to do. Then we'll come back around once we're established on that leg inbound. We really don't need to time the leg inbound because we do that for wind correction, which we'll talk about here in a little bit. And since we're doing this with distance and not time, we don't need to worry about that. Turn, we'll just get ourselves centered up on the radial. Twist, we should already be twisted to the 180 course. Throttle and talk, we shouldn't need to worry about. So that's a demo or a briefing on how to fly a little bit of a non-standard pattern and what the clearance would look like for that. So let's look at what a clearance and a holding pattern would look like if we were going to hold at a DME fix rather than a VOR. So let's assume we get this clearance, Cessna 172 Alpha Hotel, hold east of the Pine Bluff VOR 15 DME fix on the 090-degree radial, maintain 5,000, expect further clearance at 1800Z. So I'm going to go ahead and draw my Pine Bluff VOR up there. I'm going to go ahead and draw that 090-degree radial heading away to the east from the station. We'll go ahead and draw that 15 DME fix in there, so that's where we're going to be holding at. And then they told us, they didn't tell us what kind of turns to make, so we automatically assume that they are right turns. So we're going to fly inbound on the radial, and then we are going to make right turns and fly away from that 15 DME fix. They also did not tell us what type of legs lengths to use, so we assume that we make 1-minute legs. If we are tracking inbound on the 090-degree radial, we know that that is going to be a 270 heading or 270 course. So that will be the inbound course on this holding pattern. And we know that the outbound heading for this holding pattern is going to be 090. So how do we fly this? Let's assume that we're already on the 090-degree radial, so we're tracking a 270 course inbound to the VOR. They told us to hold at the 15 DME fix, so if we're coming from over here, our DME is greater than that and it is counting down to 15 DME. So once we get to 15.0 DME, we start with our 5 Ts. So time, just make sure that your timer is set up for 0. Turn, go ahead and turn to that outbound heading of 090. Twist, if you haven't already done so, if we weren't already tracking inbound on this course, we would want to twist this to 270. Throttle, again, if you'd been cleared to descend in the holding pattern, you'd want to go ahead and do that at this time. And talk, you'd want to go ahead and key up and report that you're entering the holding pattern with ATC. Once we get around, what's going to happen here is as we cross this 15 DME fix and make our turn, we're going to go under 15 DMEs. It's going to go to 14.9, 14.8, something like that as we make the turn. And then as we start turning back around, it will count back up. We know we're a beam. The holding fix, when it gets back to 15 DME and starts going up from there. So that's our cue to do our 5 Ts again. So we'll hit our time and time for 1 minute outbound. We've already turned to our 090 heading. We've got another reminder here to twist our VOR course to 270 to have correct sensing on the inbound. Throttle, we shouldn't need to do anything with that, and if you've already reported, there's no need to talk. So we'll fly this leg outbound for 1 minute, and when we get to our 1 minute, it's our time for our 5 Ts once again. So we're going to hit our timer and make sure that it's reset to 0. We'll go ahead and turn around to our 270 heading and get on that inbound course. Twist, again, if you haven't done so already, remember to check your course and make sure it's tuned into 270 for correct sensing on the inbound leg. We shouldn't need to do anything with the throttle. We shouldn't need to do anything with talking. As we roll around on the 270 heading, we should be centered up with this course. That radial should center up. So we will fly that, and again, we'll start our 5 Ts once we roll level. So time, we'll time the inbound leg, and again, that's going to be for wind correction, which we'll talk about here in just a little bit. Turn, we're already established, but if you're not established on the course, go ahead and intercept that radial, so that'll be your turn. Twist, you should already be on that 270 inbound heading. Throttle, we don't need to do anything there, and talk, we don't need to do anything there. So we'll be above 15 DME, and we'll wait till it gets to 15 DME, and at that point we start our 5 Ts and start the holding pattern all over again. So that's how it would work and how you would fly it if you're flying it at something other than a VOR, if you're flying it at a DME fix. Okay, so now we'll say we are inbound to Pine Bluff VOR from the east. We are tracking west on the 090 degree radial inbound to the Pine Bluff VOR, but they need to stop us short of the airport. Maybe there's some weather there or something like that. So they're going to give us a DME fix hold instead of a VOR hold. So they say proceed to the Pine Bluff VOR 090 degree radial 15 DME fix. Hold east of that fix and maintain 4,000. Expect further clearance in 30 minutes. So what we're going to do is we are going to fly until the DME counts down to 15, and then we will start our turn outbound. And then once we hit 15 on the outbound leg, we'll go ahead and start the time out for a minute, and then fly out for a minute and turn back around. I have my timer all set up again. We'll go back into heading mode here before we make the turn, and we are all set up to do this DME hold. All right, so there is 15 DME, so I don't need to time this leg, but my timer is set up to 0. I will go ahead and turn to the outbound heading of 090, and then twist. I already have it tuned to the radial that I need for the inbound, 090. And then throttle, we don't need to throttle. We're staying at the same altitude. Talk, we don't need to worry about that. And notice how as we're making this turn, it gets down to about 14.5 DME. So we are going beyond 15 DME as we make that turn back to the outbound leg. And then see now as we're coming through back to a heading of 090, it's counting back up. And we know we're a beam the holding fix when we hit 15 DME. So there's 15 DMEs, so the 5 Ts, I'll go ahead and time. We've already done our turn. Twist, we are set up for the inbound course. Throttle, we don't need to descend. And talk, we've already reported established, so we are good there. So we'll just fly this outbound heading for 1 minute. And notice that the needle doesn't move quite as far because we're further away from the VOR and it's not quite as sensitive. All right, there's a minute, so time, I'll go ahead and reset my timer. I'll go ahead and turn back to the inbound course, and again, I want to get on this radial, so that's the important thing, not the heading so much as the radial. So time, turn, twist, we've already twisted and got our inbound course in there. Throttle, we don't need to descend, and talk, we don't need to talk. So We'll just get the VOR centered up here, and then we will time the inbound leg to see if we need to make any adjustments for the wind. And you can see it's looking like it's not going to quite roll out centered up, so I'm going to put about a 10-degree correction into the left. I think some of this is kind of a simism. We are headed inbound though, so we'll go ahead and time the inbound leg, and then we know we've reached the inbound fix when we get to 15 DME. Looks like things are centering up there, so I'll go ahead and turn back to the 270 heading to keep myself centered up on the inbound course here. And then again, we're looking for the 15 DME tells us when we get there, and then the time tells us if we need to make some adjustments for the wind, which we'll talk about again here in a little bit. There's 15 DME. It's just a little bit over a minute, so that's looking pretty good. So I'll reset my timer. I'll go ahead and turn to the outbound leg, and we are pretty well established in this hold, and we'll just repeat this for the rest of the time that we're in this holding pattern. So that is how a hold at a DME fix works. I want to touch real briefly on holding at GPS waypoints. I will go more in depth with this at the end of the video, but I did want to mention here real quickly that GPS holding or holding at a GPS waypoint is possible, but how you do it depends on what unit you are doing it with. Most of the IFR GPS receivers in Microsoft Flight Simulator now have procedure turn holding patterns or holding patterns in lieu of procedure turns in their database, and they also have the missed approach holding patterns in the database as well. Again, this is only the IFR certified GPS receivers, so this is going to be things like the G1000, 3000, 5000, the GNS 530, the GNS 430. It is not going to be the non-IFR certified GPS receivers that are not certified for IFR in real life. That includes the G3X and the Garmin Era that's in the Icon aircraft. So those will not have this in there. But in order to fly those holding patterns, you simply have to load the point from on the approach from which that holding pattern starts or through which you get to that holding pattern, or just fly the missed approach and sequence it correctly to the missed approach, and it will go into that holding pattern automatically for you. It automatically navigates you into it. If you're coupled with the autopilot, it will fly it for you. When you get into the G1000, 3000, 5000, and then the working title things that they have done mods, the FMSs they've done mods on, and the third-party FMSs, things like PMDG and Leonardo, those units can be programmed with custom holding patterns or unpublished holding patterns. You do have to program them in the GPS receiver or the FMS, but once you get them loaded in there, they will automatically display. They will automatically give you navigation guidance, and again, if you're coupled to your autopilot, they will automatically fly them for you. Now, the GNS 530 and 430 are different. Those units were not certified to do holding when they were originally produced, and I don't think Working Title has the goal of making them unrealistic, so that's not an ability they're going to add to them. So to do holding patterns using those units at a GPS waypoint, you need to use OBS mode. It works pretty much like a VOR hold. Once you put it into OBS mode, you get the flip from the to the from, and that's how you determine where your point is and where your beam point is. So for the most part, they work just like a VOR hold, but that's how you have to do holds in those units, and I'll touch on that briefly at the end of the video as well. As you're flying the pattern, you need to make corrections for wind if you have real-world weather or if you have any wind set in the sim, and there are two ways you need to do this. The first is that you always need to adjust the time of your outbound leg so that your inbound leg time equals 1 minute, assuming that you're doing a standard hold below 14,000 feet. The second is that you need to apply drift correction for crosswind on your inbound and outbound legs. So let's take a look first at adjusting for a headwind or tailwind as we're flying the pattern. Let's assume that we have a wind that is a headwind as we're flying the inbound leg of the holding pattern. And let's assume that we hit the fix and we turn to our outbound heading. We fly that for 1 minute, and then when we turn around and we come inbound, it takes us 1 minute and 30 seconds. So what we need to do is we need to shorten the outbound leg until the inbound leg equals 1 minute. Maybe try flying the outbound leg at 45 seconds first and see what that does to the inbound leg, and then adjust from there. The opposite is true. Say if you fly a minute outbound on the outbound leg and then you turn back around and you have a tailwind and it takes you 45 seconds to fly the inbound leg, then you need to lengthen that outbound leg and until you get to a point where you're flying 1 minute inbound. So always adjust your time on the outbound leg to get 1 minute on the inbound leg. So let's take a look at how we would correct for a crosswind if we have a crosswind in our holding pattern. Just like with any other type of flying, we do want to apply a wind correction angle or a crab angle if we have a crosswind. And so let's assume that we have a wind coming out of the east or coming from the left as we're flying our inbound course. We're going to want to apply a little bit of a crab angle on the inbound course just to keep ourselves on course. A good rule of thumb for this in a light aircraft or an aircraft that flies about 115 to 120 knots of true airspeed is to divide the wind speed by 2 if you know the wind speed to get the wind correction angle if you have a direct crosswind. So for example, if we had a 20 knot wind coming directly across the holding pattern, we'd want to put in about 10 degrees of wind correction angle. But you can just, try to find the heading that keeps you on course. If you do know the wind and you want to calculate your wind correction angle a little more precisely, there is a formula for that. You want to take the wind angle or how far it is off your nose or off of your course, multiply that times the wind speed, and then divide what you get from that calculation by the aircraft's true airspeed, and that will give you the wind correction angle. So an example for this is if we had a wind that was out of 210 degrees at 30 knots, and we're flying an inbound course of 180, that means the wind is 30 degrees off of our nose. So we take 30 degrees for the wind angle times 30 knots of wind equals 900. And then the true airspeed on a 152 or 172 is about 115. So divide 900 by 115, and you get a wind correction angle of about 7.8 degrees, so about 8 degrees. So if you, like I said, it's easy just usually to find a heading that will keep you on course and determine what the wind correction angle is. But if you know the wind and you'd like to get in the ballpark or get a little more precise idea of what your wind correction angle is, that's a formula you can use to do that. So on the inbound leg, you just apply that wind correction angle and keep yourself on the inbound course. But on the outbound leg, you need to triple the wind correction that you used on the inbound leg and apply it to that outbound leg. So you'll be flying 3 times as much wind correction on that outbound leg as you do on the inbound leg. The reason that you do that is that you need to compensate not only for being pushed off course by the wind, but also compensate for the headwind or tailwind that you're going to have as you make the turns inbound and outbound. This is going to make your pattern look a little funny if you were to draw it out or if you have some sort of tracking software that can follow you around the pattern. If you have a wind coming from the side of the pattern that would result in you undershooting the inbound course as you turn on to the inbound course, your pattern is going to look a little narrower. The outbound leg is going to slant in towards the inbound leg. And if you have a wind that would give you a tailwind as you turn to the inbound leg and would cause you to overshoot the inbound leg, the pattern that you fly with triple the wind correction is going to look a little wider. But again, this is going to prevent you from overshooting or undershooting your turn to the inbound course. If you apply this wind correction as you're flying that outbound leg, then you should make a good standard rate turn on the inbound turn, and you should roll right onto the course or pretty close to the inbound course. So now that we've talked about how to fly the actual holding pattern, it's time to talk about how to get into them. Holding pattern entries are a subject that frustrates even experienced instrument pilots, but they're probably the most important technique to take away from this lesson for executing instrument approaches. So let's try to demystify them a little bit. How you enter the holding pattern depends on where you're coming from relative to that pattern. Imagine that we draw 2 lines through the holding fix, one straight down the inbound holding leg and the other one perpendicular to it. Then we'll tilt the horizontal line 20 degrees. We want to tilt the line so that it angles back towards the end of the outbound leg just a little bit. I like to think of the holding pattern, this end of the holding pattern kind of at the head, the part where the holding fix is. And we always want to angle this line back about 20 degrees so that it's chopping off a little more of the head. If we angled it this way, down towards this direction, we wouldn't be chopping off quite as much of the holding pattern. And if you think of it that way, tilt it towards the end of the outbound leg or tilt it so it chops off a little more of the kind of the head of the holding pattern. That works for right or left turns. It tells you which way to turn it. We'll also get rid of the line that we created that goes from the top of the picture straight down the inbound leg to the holding fix. You'll see this creates three different areas or sectors around our holding fix, and how we enter the pattern is determined by which of these areas we approach the fix from. If you're approaching the fix from the area that's on the same side of the holding fix as the holding pattern, you do what's called a direct entry. This is the simplest type of entry and probably the most common. To execute this entry, just fly from wherever you are in this sector directly to the holding fix. As you cross the fix, make a turn to the outbound heading of the holding pattern. Fly this heading for 1 minute, and then make a 180-degree turn back to intercept the inbound leg of the holding pattern. That's it. It's a very simple entry, and you're now established in the holding pattern. So let's take a look at an example of how this would work, say, in that VOR hold that we were talking about earlier. Let's say that we were cleared to hold on the 360-degree radial with right turns and standard 1-minute legs. That means our inbound course to track that 360-degree radial inbound is going to be 180, and then our outbound heading on the holding pattern will be 360. So wherever we're coming from in this sector, we just fly directly to the VOR. As we pass over the VOR, we do our 5 Ts. So we're going to go ahead and reset our timer to make sure it's at 0. We're going to turn to that outbound heading of 360. We will twist our VOR course selector so that it's on that 180 for the inbound segment so we can track that. Throttle, we may throttle back to descend if we were cleared to do that, and talk will go ahead and key up and report entering the holding pattern. As we get to that inbound or get to that 360 heading and roll out, again, we'll do our 5 Ts. We're going to go ahead and hit the timer and time it for 1 minute as we're flying that 360-degree heading outbound. Turn, we've turned and rolled out on that 360-degree heading, and then twist. Again, double check that you remembered to dial your VOR course to that 180 heading for that inbound leg. Throttle and talk, you shouldn't need to do anything about that on this leg. Then when we get to the end of the minute, we repeat the 5 Ts again. So time, we're going to reset our timer back to 0. Turn, we're going to go ahead and turn to that inbound heading of 180 and intercept that 360-degree radial inbound. And then twist, we should have already twisted to the 180-degree course. Throttle and talk we shouldn't have to do. And then once we roll out on that 180-degree heading and we are on course, we'll go ahead and do our 5 Ts again. So we'll start the timer and make sure that it is 1 minute till we hit the VOR, and then adjust for wind from there. And then turn, we should be rolled out on a 180 heading or whatever we need to do to track that course inbound. And then twist, we shouldn't need to do at this point. Throttle and talk, we should also be good on those as well. And so that's it. We just track to the VOR and then repeat as necessary. So that is a direct entry on a VOR holding pattern. If you're approaching the holding fix from the area that's in the opposite direction of where the holding pattern is and the opposite direction of the turns in the holding pattern, you'll want to execute what's called a teardrop entry. With this type of entry, you fly over the fix and then fly a heading that is 30 degrees away from the outbound heading of the holding pattern in the opposite direction of the way you turn in the actual holding pattern. For example, since we have a right-hand holding pattern here, we want to turn, after we cross over the fix, we'd want to turn 30 degrees left of the outbound heading for this holding pattern. You fly this heading for 1 minute, which basically puts you at the end of the outbound leg. You then make a turn to join the course inbound to the holding fix, this time making the turn in the same direction as the turns in the holding pattern. So once we've turned to that heading that's 30 degrees left of the outbound heading, we time out for 1 minute, and then we make a right turn, since this is a right-hand holding pattern and join the course to fly inbound to the holding fix. Once we hit the fix, we are established in the holding pattern, and we just start the holding pattern procedure. So taking a look at how we would fly this on that pattern that we've been discussing at Pine Bluff VOR on the 360 degree radial. So there's our 360 degree radial. We know our inbound course on that radial is going to be 180. We're doing right hand turns with 1 minute legs. So our outbound course is going to be a right turn around to 360 on the heading. So we are coming up from this teardrop sector over here. So we're going to fly directly to the VOR. And when we get a flip from the to flag to the from flag, we're going to take up a heading that is 30 degrees left of the outbound heading of the holding pattern. Again, the holding pattern turns are right, so we want to take up a heading that is 30 degrees left of the outbound heading. Outbound heading is 360, so 30 degrees left or west of that is going to be a heading of 330. So we fly that out for 1 minute, and then at the end of the minute, we do that turn back around to 180 degrees. We intercept that 360 degree radial inbound, fly it back to the fix, and then we just start the normal holding pattern procedure from there. The final entry type is called the parallel entry. This is used if you're coming from the area that's on the opposite side of the holding fix from the pattern, but on the same side as the turns are located on. With this entry, you cross the holding fix and then turn to the outbound holding pattern heading. This has you basically flying very close to the inbound leg, but in the wrong direction. You do this for 1 minute, then you make a big turn in the opposite direction of the holding pattern turns to intercept the inbound course. Once you intercept the inbound course, you fly back to the holding fix and then begin the normal holding pattern procedure. So to kind of mentally fly through how this would work, if we're coming from this area down here, what we're going to do is we're going to fly to the holding fix, and then we'll take up the outbound holding pattern heading. We'll fly that for 1 minute, and then at 1 minute we'll make our big turn around to the left to intercept the inbound course, and we make the left turn because our holding pattern is right turns, and since we're going outbound, basically the wrong way on the inbound leg or very close to the inbound leg, to stay on the holding pattern side, we need to make those turns to the left or in the opposite direction of the holding pattern turns. And that holds true whether you're doing left turns in the pattern or right turns in the pattern. So what exactly does a big turn mean? Well, the only guidance that the FAA gives us is that we need to make a more than 180 degree turn. That's from their instrument flying handbook. What I like to do is use a 210 degree to 225 degree turn. The way I like to think of this is I'm doing a 180 degree turn, or I'm putting my nose where my tail just was to get myself pointed, basically going in the right direction, back towards a holding fix, but that's still got me going the wrong way on the outbound leg now. So I need to keep going another 30 or 45 degrees, 30 to 45 degrees to get myself on an intercept course to go back and get on this inbound leg and then intercept that and then fly it back to the holding fix. So what do you use? How much do you use? Do you use 210 or 225? I would use 210 if I'm holding it like a VOR here, and a 45 degree intercept would be very aggressive. And with you being that close to the station, you might fly through the course fairly easily. So I would tend to use a shallower angle there versus if I were at a more distant fix like a DME fix, I would tend to use a 45 degree, a fairly aggressive intercept on this course. So the total of 225 degrees of turn to go and get that course, because that needle is not going to swing across quite as quickly when I'm more distant from the station. Another little cheat that you can use with a parallel entry, if you're holding at a VOR or an NDB and you have a bearing pointer on your aircraft, you can hit the fix and then fly outbound on the outbound heading for 1 minute. And then when you make your big turn back around in the opposite direction, rather than trying to intercept the course, you can just center up the bearing pointer going directly to the VOR or the NDB and just go directly to the station and then hit the station and then start your normal holding pattern procedure from there. This keeps you on the protected side, and it's a little bit easier than trying to fly inbound to a course and intercept it, and you're not going to be on the course for very long. So this works pretty well when you're holding at a VOR or an NDB and you've got that bearing pointer available. So to talk through this, how this would look at our VOR hold that we've been looking at earlier, let's assume that we were given the clearance to hold at Pine Bluff VOR on the 360 degree radial, right turns and 1 minute legs. And so we know that our course inbound to the VOR is going to be 180 in this holding pattern. We know that the outbound heading is going to be 360. So we're coming from down over in this area over here. We fly to the VOR, we get the to from flip, and we're going to do our 5 T's. So we'll go ahead and turn to our outbound course or our outbound heading of 360. We'll start our time and time for 1 minute. We'll twist, and we'll go ahead and twist it around to the inbound course of 180 so that when we make our big turn back around to intercept, we've got correct sensing. Throttle, we may throttle back to descend if we were given clearance to do that. And then talk, we'd go ahead and call up and report established in the holding pattern. And then when 1 minute is up, we'll go ahead and do our T's. We'll reset our timer back to 0. We'll go ahead and make that big turn. So again, since it's the VOR, we're going to turn left about 210 degrees to heading about 150 to intercept that inbound leg. There's no reason to start timing on this leg. We really aren't going to time the inbound leg on this one because it's going to be kind of a half of a leg. And then throttle and talk, we shouldn't need to do that. And then once that needle centers up, then we will go ahead and turn inbound and track the VOR inbound. And then once we hit the VOR and get the to from flip, then we'll go ahead and turn outbound to that 360 heading and go ahead and start the normal holding pattern procedure there. So that's what that would look like for that parallel entry at the VOR on that hold on the 360 degree radial we've been looking at as an example so far. So how should you determine which entry to use? The bottom line is that it's most effective to be able to visualize your hold and visualize your position relative to it to determine which entry you should use. It's also a good idea to do the math and figure out where the entry areas are based on courses direct to the holding fix or radials from it. For example, if we're looking at our Pine Bluff VOR holding pattern on the 360 degree radial, if we do the math, we know that the radials that surround the station that define the holding entry areas are going to be the 110 radial going off to the southeast, the 180 degree radial going off to the south, and then the 290 degree radial going off to the northwest. So if I'm on the 290 radial heading directly to the station, that means I'm going to be taking a 110 course to get direct to the VOR. And so if I'm on a 110 course going upwards around over all the way to 290, I know that I can do a direct entry. I can just hit the VOR and turn to the outbound heading. If I'm on a 290 course around to a 360 course, which is what I would need to fly if I'm flying inbound on the 180 degree radial, I know that I'm in this teardrop sector over here. And then if I'm on a 360 course back around to a 110 course, then I know that my best bet is going to be to do a parallel entry. There's also a rule or a rule of thumb that if you are on the line, if you're plus or minus 5 degrees between two entry types, then you can just choose which entry type you'd like to do. Most of the time, if you're on the line between a teardrop and a direct entry, most folks will choose to do direct. If you're on the line between teardrop and parallel, most folks choose to do the teardrop. And then if you're on the line between the parallel and the direct, most folks will choose to do a direct entry. In addition to visualizing the pattern and visualizing your position relative to the pattern, there are a few little tricks and techniques that you can use to help determine or verify which entry you should use. The most common one is probably the thumb method. What you do with this method is you're assuming that you're flying directly inbound to your holding fix, your VOR, or the fix that you're going to hold at. And you take your thumb and you place it just above the 90 degree left or right tick mark on the heading indicator or the HSI. If you're making left turns, so you're doing a non-standard holding pattern, then you want to use your left thumb on the left side of the heading indicator and just put it up there like that. And if you're doing right turns, then you want to put your right thumb on the right side of the heading indicator just like that. So what you're doing with this technique is you're using your thumb to basically visualize that slanted line like we drew through the holding pattern earlier. When you put your thumb down on the indicator, your thumb goes up about 20 degrees from that tick mark on the left or right side there, and then you can use that to kind of visualize that slanted line going across a heading indicator like that. And then you want to also visualize a line going from the airplane to the top of the heading indicator, and this creates your entry sectors. So the small one above your thumb is going to be the teardrop entry. Think T for thumb and T for teardrop. So that's going to be that small sector up there. And then the larger sector at the top is going to be your parallel entry. And then the big sector, the 180-degree sector on the bottom, is going to be your direct entry. And what you want to do to determine what type of hold entry you want to do is you want to find your outbound holding pattern heading on the heading indicator and then figure out which sector that's going to be in. So for instance, with the pattern we were looking at earlier, the example pattern where we're holding on the 360-degree radial, so our inbound course and inbound heading was 180, our outbound course was 360. We look on the heading indicator and the 360 is over here and it is solidly in the parallel entry sector. So we'll go ahead and try to visualize that and see if that works out. And if we are west of the station, heading due east to get to the station, and we're doing that standard holding pattern on the 360 radial with a 180 inbound course, if we draw out our sectors, we can see that we are indeed in the parallel sector, and that would be the best entry to make. It should be noted that these entry methods are recommended methods and not mandatory. In real life, air traffic control really doesn't care how you enter the hold as long as you stay in the protected airspace for the holding pattern. That being said, these entries are the method that most examiners will want to see used on a check ride, and they're the entries that almost all pilots use. I'll also mention that when you're flying a holding pattern in lieu of a procedure turn, you only need to make one trip around the pattern before you proceed in on the approach. So you basically just have to fly the pattern entry, and you just fly over the holding fix, do whatever outbound leg is appropriate for the holding type entry that you're doing, then make your turn around back to the inbound fix, fly over the holding fix inbound, and then you can proceed on in on the approach if you've been cleared for the approach at that point. And as I mentioned earlier, most IFR GPS units and third-party FMS units have holding patterns for things like missed approach holds and procedure turn holds programmed into their database. And many advanced GPS units and FMS systems allow you to program custom holding patterns in them. I know that the working title version of the GNS 530 and 430, which again is available to all users in the marketplace for free, contains procedure turns and missed approach holds in the database. And then the G1000 NXI, the G3000 and 5000, as well as a lot of third-party FMS units like the PMDG units and the one in the Leonardo MD80. And then any of those that are upgraded have been upgraded through Aircraft and Avionics Update 1, like the Cessna CJ4 FMS. Those units also have holds built into their database, and they can be programmed with custom holding patterns at basically any fix as well. Okay, so let's take a look at how to load a procedure turn, a holding pattern in lieu of a procedure turn. So we are headed right now direct to Sheridan Airport in Sheridan, Arkansas, which is about 20 miles to the west-northwest of Pine Bluff, Arkansas. Identifier there is going to be 9 Mike 8, and we're going to load up the RNAV GPS to 19 and show you how to load up that procedure turn or that holding pattern in lieu of a procedure turn. So, and this is pretty much how it works on all these Garmin units. See, I can probably get a little closer here. So we'll go to the procedures key here, and that's where we'll load up all of our approaches, arrivals, and departures. We will do select approach, and then we will go to the RNAV to runway 19, and all you have to do to load up a procedure turn is load a fix from which a procedure turn or holding pattern will be flown. And we only have one choice, vectors or Joves, and Joves is the initial approach fix, and we do have to do a procedure turn if we are not getting radar vectors if we do it from Jove. So we'll go ahead and load that up. Do we want to go and activate? I do want to go ahead and do that. So I'll go ahead and hit enter. And you can see it's got Joves and then the hold at Joves, and then it has the rest of the fixes going in on the approach. Actually, we'll back up here. Yeah, so that is all correct there. And then if we go ahead and go out to the map here, you can't quite see it right now, but once we get a little closer, you'll be able to see the holding pattern depicted. As we get closer, it'll actually tell us the type of entry that we want to do for that holding pattern. And you can see as we get closer to the fix here, it actually depicts the little holding pattern here. We're coming from the area that we would want to do a teardrop entry, so it depicts that teardrop leg out to the outbound, the turn back around to the inbound, and then the rest of the approach course there. So it's all depicted out there for us, and it will automatically fly it for us. All we have to do is keep it nav'd up to the GPS, and it will fly the holding pattern for us. And you can see there, as we get within a half a mile, it actually tells us what kind of entry we're going to do. So if depicting it weren't enough, it actually tells us what we need to do once we get to the fix. You see now we've crossed over the fix. It's activated the holding portion of the procedure, so it'll fly this teardrop right on around back onto the inbound course, and then it'll fly the rest of the approach on the rest of the way in. And you can see now it is established on the inbound leg to Joves, and once it hits Joves, it will exit the hold, and it will go ahead and proceed in on the approach. And you can see now it has passed the holding fix, and it's proceeding inbound on the rest of the approach. So that's how you load and fly a holding pattern in lieu of a procedure turn on a GPS approach using the Garmin units. Now let's transition over and take a look at how they sequence into the missed approach holds. All right, so we are making our way on to the approach here, and I'm just flying this approach at 1900 feet and just at a cruise speed. I'm not actually demonstrating the approach, we're just demonstrating how the missed approach hold works. So what's going to happen here as we hit our missed approach point here at the runway 19, it will go into a suspension mode, which we then need to take it out of, and then we can re-engage the nav and have it navigate out to our missed approach holding pattern. And we can see that our missed approach holding pattern is loaded in the database. It is already out there. We just have to let sequence the unit onto the missed approach, and then it will automatically fly it just like it flew the procedure turn holding pattern. All right, you can see we've crossed our missed approach waypoint. It's gone into the suspension mode. So we'll go ahead and disengage that suspension mode by pressing OBS. Now the nav leg to the missed approach point is, or for the missed approach procedure is active, and we do still have nav engaged, so it will go ahead and track out there automatically. It's 10 miles till we get out to the hold, and you can see the hold is already depicted there. And it will determine our entry automatically, just like it did with the procedure turn hold, and they will then enter the hold, and then it will fly the hold until we give it somewhere else to go. And as you can see, as we get closer to the hold, not only is the hold depicted, but the entry into the hold is also depicted, and just like the procedure turn hold, it will tell us about half a mile prior to the fix the entry that it plans to do. It will then fly that entry, and then it will fly the holding pattern. Again, it will stay in that holding pattern until we get into the flight plan or take it direct to some other waypoint, or putting it in heading mode or something like that. It will fly that heading pattern for us. So it tells us hold teardrop, so it's going to do a teardrop entry, and it'll do that teardrop entry, and then it'll just fly the holding pattern until we tell it to go do something else. So let's take a look at how to build a custom hold using the G1000. So I am inbound on the Bremer 7 arrival into the Kansas City area from the Kirksville transition, and I'm approaching Phonics intersection. And we'll assume that I get the following clearance from ATC as I'm inbound on the arrival. Cessna 173 Alpha Hotel, cleared to proceed to Phonics, hold as published, maintain 4000, EFC at 1800 Zulu. So I know that the hold is going to be as published. I know it's going to be right turns. It doesn't say anything about length, so I know it's going to be 1 minute legs. I know the inbound course is going to be the same as this leg of the arrival, which is 237 degrees, and the outbound course, or the outbound heading, will be 057. So what I'm going to do is I'm going to go to flight plan, and I'm going to activate the small cursor, and I'm going to go to Phonics, and then I'm going to hit menu, and then I'll use the big key or the big knob to scroll down to hold at waypoint. I'll hit enter, and then it gives me all the fields that I need to know to hold at that intersection. So it's hold northeast of Phonics. That's what I want to do. I want a 237 course inbound, so I will adjust that to 237, and I can either put the inbound or the outbound. I can do the legs in time, or I can do it in distance, but they said to do it with 1 minute, or it didn't say anything. And then I can choose the direction that I use on the hold, right or left. So all of that looks good. So I will go ahead and go down to load and go ahead and press enter. And I'll go ahead and go out of the flight plan screen. And you can see if I zoom in here that it has the hold depicted here at Phonics as it is on the arrival. And as it gets to Phonics, it will enter the hold, and then just like it on the Garmin 530 and 430, it will tell me with the entry type as I get there. Although I can see from looking at it, it looks like it's just going to be a direct entry. And I misspoke earlier, it does not tell you the entry type on the G1000, it just tells you the next direct track or the next desired track. I guess it figures since it's depicting the entry for you, you can figure out what it's going to do. And so as we approach the holding fix here, it will go ahead and activate the hold. So there it's activated the holding pattern, so it's going to go ahead and start its turn. And it will just go into this holding pattern and fly this holding pattern until we tell it to do something else. And with a programmed GPS hold like this, there's no reason to do the timing. It will automatically adjust the time on the legs for you. And then in order to get out, and one other thing I'll mention is that you can do this at any intersection. You can do it at any waypoint that you can load into the GPS. You can create a holding pattern. So you can hold basically anywhere just by going into that menu and programming the hold off of that waypoint. So you can do it on GPS waypoints, you can do it on traditional fixes, you can do it on VORs, NDBs, anything you can load, even in airport, anything you load in the GPS database you can hold at. And there's a couple different ways to get out of the hold. Probably the most common is going back to flight plan and highlighting or clicking the middle knob here and then going down to the hold and hitting clear. That will delete the hold. It'll ask you when you do that, do you want to remove the hold? You click OK, it removes it, and then it will turn you back direct to the holding fix and let you proceed on the route from there. The other ways that you can do it, or the other way that I know of, is you could just go to the next fix you want to go to and hit direct, and then that would send you direct present position to that next fix, and that would also get you out of the hold. So that's the basics of how a GPS hold works on the G1000. Okay, so same day, a different plane. We're now in the Cessna 172 Classic with the GNS 530 and 430. We're still coming inbound on the Bremer arrival into Kansas City. We're approaching Phonics intersection. But in the GNS 530 and 430, we can't program a hold like we can in the G1000. So we're going to have to do this in OBS mode instead. I do have a full tutorial on exactly how OBS mode works, what it does, and I will leave a link to that in this video. That is for the G1000, but they basically work the same, except that you use the OBS on your number one VOR indicator there while it's in GPS mode to change the course on the OBS. But OBS mode basically turns any intersection that you're navigating to into a VOR, so you can use it exactly like a VOR. So as we approach the intersection here, what we're going to have to do is we're going to have to put it into heading mode, and then we are going to have to turn this to OBS mode, and then we're going to have to do this manually and fly this hold basically like it is a VOR hold instead of a GPS hold. So as we approach the waypoint, we'll assume that we got the same holding clearance that we did earlier. Cessna 172 Alpha Hotel, proceed direct to Phoenix intersection, hold as published, maintain 4000, expect further clearance at 1800Z. So as we get close to the station, we'll go ahead and set up for the hold. We'll go ahead and put the autopilot in heading mode. We will go ahead and put the OBS into OBS mode. And as soon as we hit the station, we know we've got pretty accurate DME here. We're waiting for the flip from the to the from, and that will tell us to go ahead and start the holding procedure. So there's the flip from the to the from. I'll go ahead and turn to the outbound heading of 057 time. I just want to make sure that my timer is set up for timing the inbound leg, so it's set to 0 and it's in the elapsed timer, so that all looks good. Twist, again I want to twist this to 237 so I've got an accurate inbound course, and then throttle, I don't need to throttle, I'm going to go to holding speed, and we would go ahead and report established in the hold. Okay, so we're on the outbound heading, but we're waiting until we're abeam the holding fix, so we're waiting for this to flip from a from to a to. There it is, so we'll go ahead and time. So it's counting up, we'll time out for a minute. Turn, we are on the correct heading, 057. We don't need to, well, we got the twist done already. It's on a 237 for an accurate inbound course. And then throttle we don't need to do, talk we don't need to do. So we're just going to time out for a minute and then we'll turn inbound. So there's my 1 minute. So I'll go ahead and reset the timer. I'll turn to the inbound course of 237, excuse me. And then twist, it's already twisted to that 237 course. Throttle, we don't need to do anything with that, and we don't need to talk. So again, I'm intercepting this inbound course, and I'm going to fly this course inbound. It looks like I'm rolling out just a little bit to the right of the course, so I'll put a little correction in there, but I am headed towards the inbound fix, so I'll go ahead and start the time. We'll get that course nice and centered up here. And then we'll time for the inbound for 1 minute to make adjustments on our outbound leg. And then again, it's just like a VOR hold. I just want to go until I get the flip from the to the from. Nice thing about a GPS is it's not going to get more sensitive as we get closer to the fix. And again, since it's GPS, we've got very accurate DME here. So, or not DME, but distance. It's not DME. It doesn't have that slant range error, so that's good. Approaching our waypoint. There's the flip from the from to the to, so we can go ahead and turn outbound to that 050 heading. We'll reset the timer, and we just hold until we are cleared out or we've decided it's time to go elsewhere. And so that is how a GPS hold works in a unit where you cannot program a hold into the GPS. You just use the OBS mode. So that concludes this video. Hopefully it's given you the knowledge you need to enter and fly holding patterns in a variety of different situations. As always, if you've enjoyed the content, don't forget to like the video, subscribe to the channel, and ring the notification bell to be alerted to new content. Thanks for watching, and we'll see you next time.